Welcome to another lecture on digital electronics. In this video, we will be seeing what is a clocked SR flip-flop. So the flip-flop that we just studied is an SR flip-flop, and we have seen all the four conditions of S and R and what are the respective outputs that we get. Now we will be seeing what is a clocked SR flip-flop. The reason for providing a clock is I do not want output at a random moment of time, and hence depending on the clock, I will have my output getting reflected on Q and Q bar. So that is the meaning of a clocked SR flip-flop. What is a clock and how it works? So at the input of this gate G3 and G4, I will connect a clock signal. Clock is nothing but a train of pulse, a train of square or a rectangular pulse which is given at the input of G3 and G4. Now there are four types of triggering which are being used. What is triggering? Triggering means whenever a particular trigger of the clock is present at the input, only at that point of time your entire flip-flop will be active and will generate the corresponding output to the corresponding input what is present at that point of time. When there is no triggering for the clock given, then the flip-flop will not change its state. It will retain the memory because it is a memory element. It will retain the value of Q, whatever it is, at whatever state it is. Either it is 0 or it is 1 or whatever the state is, right? So this is a clock signal. There are four types of triggering being used. So what are those four types of triggering? I will just move down to the next page to write. So the first one is positive level trigger. This positive level trigger is the one that has been drawn in orange. So whenever this positive level of the clock will appear at the input of this SR flip-flop, that is when the circuit will become active, and that is when the output will get reflected corresponding to the input present. There is something called as negative level trigger. This is positive level trigger. Negative level triggering is the one that has been drawn in blue. So whenever this part of the clock comes at the input, at that point of time your circuit will be active. The next one is positive edge trigger. Positive edge, I will draw in a different color, is this. The one that is going from 0 to 1. This is your positive edge. That is your positive edge trigger. And the last one that you have is a negative edge trigger. Negative edge trigger. And this is the most commonly used negative edge. The falling edge where the clock is going from 1 to 0. And so on, right? So these are four types of triggering that are being used with the clock for the circuit to work. The most common is the one that has been drawn in red, negative edge trigger. Why? The reason being, positive edge and negative edge are impulsive. Means what? They change the movement, or the change is very, very impulsive. It immediately goes from 1 to 0 and immediately comes down from 0 to 1. It is very, very impulsive. So output gets reflected only at these points of time. Whereas in level edge, in the level triggering, positive or negative level triggering, if you see here, there is a stipulated duration of time in which the flip-flop is able to change its state. And this is dangerous in many situations, which we'll be seeing in the further lectures. So this time duration which is given for the flip-flop to change its state is a bit tricky to understand. Whereas in the edge triggering, either positive or negative, the response is very impulsive. It will change the state only in that duration of time, which is at this moment only, and hence it becomes easier for us to get the output. So I hope these clocks are clear. Last thing before I close this lecture is a concept of preset and clear. What is preset and what is clear? So I have one more input here connected. This is called as PR or preset, and I have one more input here connected. This is called as clear, CR or clear. Why do we require these two additional input lines to the flip-flop at the NAND gate G1 and G2? Say before starting my circuit, I want that as soon as I start my circuit, the output of Q should be 1. When that will happen? When I apply preset is equal to 0. Please remember, preset and clear are active low. What do you mean by active low? Whenever 0 is given to them, that is the time then they will become active, and hence they are called as active low. So if I want the state of Q is equal to 1, I'll have to make preset 0. See what happens. If you remember the truth table which we just drew for NAND gate in the previous lecture, 0, 0, 0, 1, 1, 0 and 1, 1. For all of these, 0 into 0 is 0, but NAND will do the reverse, 1, 1, 1 and 0. So since one of the inputs to this NAND gate is 0, which is active low, if one of the inputs to the NAND gate is 0, what are the outputs? The output is by default 1. So whenever you do preset is equal to 0, this G1 will always give you 1, which means I am presetting, my value of Q is 1, which means I am presetting the value of Q to be equal to 1. And of course, when this is 1, when this 1 comes in a feedback, your Q bar is always going to be 0 because they are complement of each other. In the second case, when I want to clear the flip-flop, what do you do when you want to clear? I will remove this to understand. When you want to clear the flip-flop, I will give an active low at the clear pin. When I give active low at the clear pin, again, since any one of the input of this NAND is 0, what is the output going to be? The output is going to be 1. Correct, no? See, any one input is 0, my output is 1. My Q bar became 1. Since my Q bar is 1 now, what is my Q going to be? The complement of it, which is 0. And by doing this, I have just cleared the value of Q from anything to now 0. So clear will, when given active low, will clear the value of Q to 0. When preset given active low 0, will set the value of Q to be equal to 1. This is for preset. Please understand. And what you have to give for preset? Preset value and clear values both are active low signals. Both has to be given 0 for setting or resetting the value of Q. I hope the concept of preset and clear is also clear. Lastly, we will draw the symbol of the SR flip-flop with all the elements that we know. So this is my SR flip-flop. So I have a box like this. This is your SR flip-flop. I have S, I have R, I have a clock. Then I have Q as my output and Q bar as a complement of it. This bubble shows it is active low, preset and active low clear. So this is how a symbol of SR flip-flop looks like. I hope the concept is clear. I will stop the video here. Thank you for watching.